see, I'm going to write this down because I see some of you still looking off into nowhere. I'll be able to compare the size of fractions and put them in order from smallest to greatest. Hi. Good morning. Now your brother's in my math class too, right? Okay. All right, here we go. Decide whether the following fractions are closer to 0, a half, 1, or 1 1/2. So we're going to use the space to the right to do that. And this one here could be something that I'm sure all of you can do. So what we're going to do is we got 1, 2, 3, 4, 5, 6, 7, 8, 9. We got 18 that we need to sort. This 1/5, is that closer to 0, 1/2, 1, or 1 1/2? Someone raise your hand. Okay. Who didn't? Yeah, Isaiah. It's closer to 0. I agree with you. It's closer to 0 than it is to any of those. But you guys have a table, so go ahead and put the 1/5 in that table. I don't have one here. See how there's a table to the right? There's boxes. Yeah. Sure, then we'll mix it up. What do you think for the 4/5? Yes. It's almost. And do you guys have a visual? Isaiah, what's your thought process when you see 4/5?
Well, like, I think like 4/4. I think of like, let's say 4/5. Like, I think of fifth, like 1 whole.
Okay.
And then I take it backwards and then say, okay, so 1 after 5, 1 before 5 before, so that's closer to 1 whole.
Yes, so it's 1/5 away and it's close. Okay, I see what you're saying. Yes. Good. Yes, Toby.
I usually think of, was it times 2? So in this case it would be 8 times, or it would be 4 times 2 and 5 times 2. That makes it 8 and 10.
Okay. So you like thinking of tenths more, is that what you're saying?
Yeah. So then 10 is easier to see if it's half or if it's 4/5, or is it a whole? And so I'm making it the 8/10, and I see that it is closer to the 1.
Okay. Oh, I did. You're right. So yeah, that's actually going to be equivalent fractions there, like we did the other day. So if that works for you, that's fine. But it's actually going to be the same notch on a number line. So then we have 1/3. 1/3. What do you think? Closer to a half. Okay. Closer to a half than 0. I'm going to agree with you on that. How about 2/3? 2/3 on the other hand. Yep. 1 whole. I'm going to say yes. Okay. 1/10? Yeah. 0. 6/10. Yes.
I'm gonna say 1 because it's over half.
1 because it's over half. I'm going to say not 1. I'm going to say 1/2 because it's actually 1/10 away from 1/2. 5/10 is a half. Equivalent fractions. Now we have 7/10. Yeah. It's going to be closer to 1/2 because it's only 2/10 away from 1/2 and it's 3/10 away from 1. Yes. What do you think?
1.
Now we're closer to 1. Now we're closer to 1. Then we have 3/8, which is going to be closer to 1/2. We're not going to do that whole second row because our class is not 90 minutes long. Sort your data on the table provided. Okay? Salud. Human. There we go. Vocabulary. Is that somewhere on here? There it is. Yep. Benchmark. Fractions that are reference points. You're writing that. Fractions that are reference points. You can write that right there. Fractions that are reference points. Or points? Yeah, points. As in you refer to them. In your head, you recognize certain fractions, and other fractions are related to that. I'm trying to see how much my hair is poofing out. For example, 5/8 is closest to 1/2 because we know that 4/8 is 1/2. So you should write down that example as well, please. For example, 5/8 is closest to 1/2 because we know from doing equivalent fractions that 4/8 is equal to 1/2. Using benchmarks to compare the fractions. Compare each pair of fractions using benchmarks and other strategies. Then copy the fractions and insert the less than, greater than, or equal to symbol. Describe your strategies. So we have 5/8 is something compared to 6/8. You have an answer for that one, Jack? What do you think? Greater than? Let's look at it on, well, what does this simplify to? Oh, it's going to change the screen. What does 3/8? Does 6 and 8 have a common factor? Yes? Would you know what it is off the top of your head? They're both even. 2. So 2 can be reduced to 3/4, right? So that would be something that 3/4, does that ring a bell as far as benchmarks in your brain goes? Because everybody has different concepts of it. 3/4? 1, 2, 3, 4. So here's 1/4, 1/2, 3/4. So it's going to be somewhere around here. Actually, it's going to be right there. Now, how about 5/8? 5/8. Is that going to be bigger or smaller than 6/8? smaller because 6 is bigger than 5. Yeah. 6 is bigger than 5. Whenever you have the same denominator, it's just like it was when you were in second grade, when you would have to say, is 2 greater than or equal to, greater than, less than, or equal to 3? Okay? Because all you could have, you can have whatever in the denominator, 2,341sts. Okay? Yeah, 3 will always be bigger as long as you have the same denominator, like it is in that one. So they warmed us up pretty easily. So that one's going to be less than. We have 5/6 and 5/8. Earlier this week, I talked about a way to know which number is bigger. What do you think, Morgan? Yes, good. If the denominator is smaller, you have bigger pieces, right? And the numerator, if it's the same, you have smaller pieces when the denominator is bigger. So which one of these, with that in mind, is it going to be 5/6 or 5/8? Ms. Baer, what do you think? Five six is greater than. Yes, you are correct. 5/6 is greater than 5/8. 5/6 is greater than 5/8 because the denominator is smaller and the numerator is just as big. Then we have 2/3 and 3/9. Ooh, that's 4 different numbers on that one. Karstens? 2/3, why do you think that? Good, you were doing equivalent fractions. What you just found there was the least common denominator. Like our homework last night, it's also a least common multiple. Least common multiple. So what Carson just did was, he knows that this here is the same as doing that. Okay, the numerator multiplies by 3 because the denominator had to be multiplied by 3. And you could also reduce the one on the right. That would also work. Number 4, 13/12 and 6/5. Here's one of those big denominator things again. Hunter? I'm sorry, say it again? 6/5 is greater, he says. Let's see. Let's see, we're going to do 13/12, and when we have the denominator is bigger, we have smaller pieces, and those numbers are pretty close to each other if we were to multiply it by 3-ish. Okay? What do you think? More than equal to? If it was equal to, you could multiply 5/6 easily into getting 11/12 or 6/12. I said that backwards. 13/12 and 5/12. Yes.
Yeah, but that's still over 5, so that'd be 5 and 1 and 1/5. And that would be
1 and 1/5, 1 and 1/12. Beautiful. I like your state of mind. We're going to look into that. Let's do this. So we're trying to figure out if it's 13/12 is greater than or equal to, or greater than, less than, equal to. We're trying to figure this out. There's 2 different ways of doing this. First, I'm going to show you the way that we just figured out. Well, we didn't figure out. What's your last name again? Miss Archer here figured out. She realized that 6 and 1/5, or 1 and 1/5 is the same as 6 and 1/5. This guy over here is the same as 1 and 1/12. Now, which one is bigger, which one is smaller when you look at it like that? Yeah. Which is that bigger or smaller? Is that bigger or smaller? Okay, there you go. Yes, that one is bigger. There's another way to look at it. I'm going to find the let's see. the least common multiple of 12 and 5. And I'm going to use the ladder method because the list method takes forever, right? Yes. And there's nothing that goes into both of those, so that means I just have to multiply. 12 times 5, which is going to be 60. So I know the denominator has to be 60. Okay, the denominator has to be 60, and I'm going to redo both of these. I'm going to get rid of these. Orange. So in order to get 60 in the denominator... Oh. Interesting. 60 in the denominator here, 60 in the denominator here. And what's happening to 5 to get 60? What's happening to 5 to get 60? Toby? It's times isn't a verb, but it's multiplied by 12, yes. It's being multiplied by 12, so I have to do 6 times 12, 60 plus 12. No, 60 plus 12. Yeah. 60 plus 12. Okay? Then I have to go to the other side. What's happening to 12 to get to 60? It's being multiplied by 5. So then I have 5 times 10 is 50 plus 15, 65. Now, we have the same denominator. Which one is bigger? Katie, which one is bigger? 72. 72, clearly, with the Lincoln Wildcat colors. Okay? Two different ways of doing it. Both are yummy. Okay, then we have 6/12 and 5/9. Okay, we have 6/12 and 5/9. 6/12 is the benchmark that you should be looking at is half. What would be half of 9? What's half of 9? 4.5. Which is bigger, 4.5? Is 5 bigger than 4.5? So this is on the This is on the bigger side. 5/9 is on the bigger side of a half, and 6/12 is half. Yes. You want this one? All right. What you got?
Well, 3/4, since we have 12, 16, the other two numbers can be, like, you can change them and make them greater, so the denominator is, the two denominator.
Show me. So right now we are trying to see how it would be easier to compare these so you can tell. Easiest comparison so I know that I'm going to do it right. So they both are 12 and 16 because what Mackenzie did was she multiplied the numerator and the denominator by 4, and we realized that that is an equivalent fraction. Equivalent fraction. Good job. Use benchmarks and other strategies to help you write and set these fractions in order from least to greatest. Least to greatest. So we'll do 2/3, 7/9, and 3/7 together, and then I'm going to see if you can do that second one by yourself. So, what are these benchmark fractions close to? Okay, this 7/9, what is that closest to? Nate? This is closest to 1. Good. 2/3. It's going to be close-ish to Carson's? Close to what? 1. 1 or 1/2, right? How about, that's, it does. That's gross. Okay. And then 3/7. 3/7 is close to what? Yeah. Close to a half or 0. So with that in mind, I know that 3/7, then 2/3, because that's closest to 1 1/2, and then 7/9. And as far as how do you know, you would say, you'd write the things that I wrote next to the fractions. We use benchmark fractions. Or first off, write down what I was writing. Yes, sir. Yes, because that's the instructions say, least to greatest. Because we did 2/3 was closest to 1 or 1/2, 7/9 was closest to 1, and 3/7 was closest to 1 1/2 and 0. Yeah. I think I should have had a Band-Aid. 1 second. 2/3, 1 or 1/2? No, because 2/3 is closest. 2/3 is closest to 1/2 or 1. Whereas 7/9 is closer to 1. All right. That's not it.
Hopefully our Band-Aid I have to go down to the nose.
No, I should have some. There they are.
Good, you do.
Yay.
Yeah, I don't have to walk so far.
Yep.
That's a cool paperclip.
Hey, thanks.
I like the bee paperclip.
Yeah, a lot of people love those paper clips.
It's cool. They're tiny too.
Mm-hmm.
Sometimes the tinier the better.
Just like a cut.
Yeah.
So number 2, have we gotten started on that one yet? I want you to try that one. You do number 2. And I want you to show how you know. And that's least to greatest?
Oh, I do it that.
Right, okay. Let's see here. Very close. Very, very close. Mm-hmm. That's correct. You mean that's what you got to figure out if you can to see what you can do with the least common denominator?
You're trying to figure it out in my head right now.
Right,
Write it down.
exactly. I've got right there, yeah. Think about which is bigger, 1/6 or 1/5? 1/5 is bigger. So what that's saying is there's a bigger gap between 1/5 and 1 and 1/6 and 1. This one here, possibly. Here, why don't you sit in Gabe's desk? It's much warmer on that side of the room. You're not writing on yourself in here, are you? Good. Don't. All right. 4/5. Okay. I see a lot of different answers. Let's talk about this. As far as benchmarks go, this guy is only 1/5 away from 1. Okay? This guy here is definitely going to be the smallest because 4/12 is 1/3. Okay? So we know that that's going to be the smallest. This one here is 3/10 away from 1. This one is 1/6 away from 1. So now we have to think which is bigger, which is smaller. 3/10, 1/6, or 1/5. Because all of those, almost all of those, have their benchmark is 1. Toby?
5/6.
5/6 should be next, or that? What are you telling me about 5/6?
5/6
5/6 should be the greatest because it's only 1/6 away from it. So I'm going to put that guy right here. 5/6 should be the greatest. Excuse me. Then which is bigger, 1/5 or 3/10? What do you think? 1/5 is going to be a greater value than 3/10, you're saying? Okay, so that means that the next one that we would use is 7/10. Because 1/5 is the same as 2/10. Okay, then the next would be 4/5. So you had to compare how close, how far are they from each other in order to do these benchmarks. You might want to you might want to create a number line and mark them on there so you don't have any silly mistakes or isn't as difficult as it might be. And you have a number line actually on your notes right below it. Yeah. Yes. Fractions greater than 1. How would you... Yes. 4/5. So 4/5 would be 4/5 and 5/6. We would want to find the least common multiple of 4/5 and 5/6. So we would have 30. So we have 24, 30, and this got to be multiplied by 5. So 5/6 gets it by 1/30. Woo! Woo! That's so fun. How would you label the marks in between each whole number? If you made a mark halfway between 2 and 2.5, how would you label it? So let's make a mark between 2 and 2.5. Whoa. So here's 2. Here's 2.5. What should this guy be labeled? That's a little bit off. What should that be labeled? Yeah. 2 and 1/4. You are correct. 2 and 1/4. 2 and 1/4. Beautiful. Two and 1/4. Vocabulary. Mixed number. A mixed number has a whole number part and a fraction part. For example, 2.5 is a mixed number because it's a whole number and then a fraction. Yes. Yes. Yes, you will write the example. Yes. Class is over in 7 minutes. Can you hold it? Thank you. The mixed number has a whole number part. And a fraction part. Did you get it? Done? Cool. Thank you. Fractions greater than 1. Can 2.5 be written as a fraction? 2.5 be written as a fraction? Okay, 2.5 is right here. How can it be written as a fraction, Isaiah? 5 halves? Let's look at that. Let's see. We've got 1 half, 2 half, 3 half, 4 halves, 5 halves. Yes. Good. And as we know, with equivalent fractions, we can have it represent a lot of other things as well. A lot of other things, as long as it's multiplied by the same on the top and bottom. Yeah. You sure can, you big silly. Yes, 5/12. 5 halves. Vocabulary. Oh gosh, writing again. Whoa. Improper fractions are fractions where the numerator is greater than the denominator. For example, 5/12 is an improper fractions. They put their elbows on the dinner table. That's improper. Unless you're eating burgers, then you're allowed to have your elbows on the table. Improper fractions are fractions where the numerator is greater than the denominator. I am the denominator. No, but I'm running. The denominator. I make people running for president to be not nominated anymore. You get it. Hunter gets it. Bad teacher joke. What about it? I want you to write the example down, yeah. Of course you have homework tonight. You got 3 days to do it. Of course you have homework. Oops. Give your extra over to Carson's. Give your extra over to Carson's. Yeah, his first name's Colton. So this would be a closing, the things for you to reflect upon. The strategy that we found for finding equivalent fractions. Quiet, please. We had a couple of them. What was one of them? What was one of the ways that we found equivalent fractions? Yeah. Sure. Yep, so we found the least common denominator by multiplying each of the fractions. Good. What else? Everybody, turn your homework over. I want to see blankness. What's another one? Yeah. Yes. Oh, we didn't because that's right. Toby, what was another one? Okay. Another one that we found was we used benchmark fractions. We went to something that's very close to it. Then we had to compare which one was actually bigger when we put them in order. When we're working with fractions greater than 1, we can write it in a mixed number. And we actually didn't go into detail about that, but this is how you find a mixed number. If we have, for example, 2 5/8, what you do is you multiply 2 and 8, then you add 5. Okay? I don't think there's going to be anyone that big. So you would have 16 plus 5, 21 eighths. Okay? Cool. And we have 60 seconds for us to start our homework. And you may begin. Yeah. This is way too easy? I love hearing that. I love hearing this is way too easy. Yes, that is our homework. Yeah. Bye, guys. You have homework this weekend. Don't forget. Yes.